This section is over graphing polynomial functions. We've already graphed a few polynomial functions. We've learned all the details of how to graph linear functions and all the details of how to graph quadratic functions. Those are degree 1 and degree 2. But we want to be able to graph any other polynomial functions, so degree 3 and higher. So we're going to kind of summarize the rest of them all in the same steps, starting with this video here. So first, let's review what a polynomial is, and then we'll start to see these steps of how to actually graph them. So I have included all the definitions that I included earlier of what a polynomial function, the two formal definitions provided by the book, as well as my simplified definition, a mathematical sentence of nice operations. And by nice operations, I mean addition, subtraction, multiplication, and exponents. So in our polynomials, we should not be having any complicated operations like absolute value, square roots, or anything beyond that. And you can see that I've listed a couple of examples down there, f of x and g of x, and we can see that those two examples fit all definitions of our polynomial. So now that we are reminded what a polynomial is, let's review some of the vocabulary words that are associated with each part of the polynomial. So I have listed all of them here, and I suggest that you pause the video and take some time to review all of them. But I'm going to focus on a select few because that's going to help us in this video, to help us graph all of these polynomial functions. So the ones that we definitely need to be reminded of this time are the degree of our polynomial, and that is the highest exponent of the polynomial. The leading term of the polynomial, and remember terms are pieces separated by the plus signs. So the leading term is the one that's associated with the degree, or the one that's associated with the highest exponent. Now connected to the leading term is the leading coefficient. So coefficients are the numbers in front of the variables. So our leading coefficient is the number associated with the highest exponent. So, our first step in graphing polynomials is to figure out what the end behavior looks like, meaning what's happening on the very left end of this graph and what's happening on the very right end of the graph. The way that we find the end behavior is by using the leading term test. So that's one of those vocabulary words. We need to be able to pick out the leading term. And associated with that leading term is the leading coefficient, the number in front. It's going to tell us something, whether it's positive or negative. And the other piece is the degree, and that's going to tell us something depending whether it is even or odd. So once we put all of these options together, that's going to give us all of the options for the end behavior. So in these two examples down here, let's quickly pick out what the leading term is, and then whether the leading coefficient is positive or negative, and whether the degree is even or odd. So in my first example, the leading term is 7x cubed because that has the highest exponent. My leading coefficient is negative 7. So this would be a negative leading coefficient. And my exponent, or my degree, is 3. So this would be an odd degree. Now, in the next slide, I will show you what a negative odd polynomial is going to look like and how that affects its end behavior. So I suggest that you pause the video and see if you can pick out the leading term for example 2, and then beyond that, pick out whether the leading coefficient is positive or negative, and whether the degree is even or odd. Okay, so this one's a little bit more complicated, but not much, because our leading term is actually at the end of the polynomial. This is not written in descending order, so if you picked your leading term to be this here, that is incorrect because we always want the one with the highest exponent. Now our exponent, or our degree here, is 4, so our degree is even. And our leading coefficient is 5, so this is a positive even polynomial. So now that we reviewed what the leading term is and how to pick out the leading coefficient and the degree, let's see how all those partnered together affects our end behavior. So to help us summarize the end behavior, I have drawn this chart here, but notice that it's not filled in. I suggest that you don't memorize the way that the chart is drawn. I suggest that you memorize the way we fill in the chart. It's going to be easier to memorize the mechanics behind it rather than memorize the picture itself. So we're going to still use our leading term test depending upon the sign of the leading coefficient, which is portrayed down here on the left, and the degree of our polynomial, which is going to be used up here on the top. So the way that I fill in this chart is with information that we already know. Let's talk about an even polynomial at the moment. And to do that, let's talk about an even polynomial that we already are very aware of. Let's talk about a quadratic polynomial, which is a degree 2 polynomial. We just talked about the graphs of these are parabolas, and our parabolas either open up or our parabolas open down. So the end behavior of degree 2 polynomials is the format for the end behavior of all even degree polynomials. Meaning what's happening on the very end, what's happening on the left and the right is going to match if I have an even polynomial. So they're either going to be both up on the left and the right or both down on the left and the right. And whether it opens up or opens down depends on our leading coefficient. So the formula looks something like ax squared plus bx plus c, where our a is the leading coefficient. If our a is positive, then both ends open up, and if our a is negative, then both ends open down. So that's the format for all even degree polynomials. So if I have a positive even, my left end behavior is up, and my right end behavior is up. If I have a negative even polynomial, my left end behavior is down, and my right end behavior is down. So even end behaviors always go the same direction, both up if it's positive and both down if it's negative. Now let's fill in what we know about odds. Well, if I want to focus on an odd polynomial, let's go to the one that we already know. A linear polynomial has the equation y equals mx plus b, where the power of x is 1 or it's odd. So most linear polynomials can be drawn as a line going up from left to right or as a line going down from left to right. Now, we know if it's going up, it's because we have a positive slope or because our leading coefficient is positive. So all positive odds are going to go down on the left and up on the right. If our line is going down from left to right, it's because we have a negative slope or because our leading coefficient is negative. So all negative odds will go up on the left and down on the right. So this fills in the end behavior for all polynomials using information that you should already know at this point. So I have a better drawn graph here, not just my chicken scratches, but an actual official picture, so we can see the end behavior of any graph. Now notice the arrows of my blue lines are not connected because this only tells us the end behavior. This only tells us what's happening at the ends. So this is not going to tell us what fills in between these arrows. And that's what the next steps of these are going to be. But before we get there, let's actually do some official examples of finding end behavior of any type of polynomial equation. So I have a first example here. F of x equals negative 4x to the 5th plus 6x to the fourth plus 2x. The first thing I'm going to do is pick out my leading term and whether it's positive, negative, or even odd, and then I'm going to pick out the end behavior that's associated with it. So my leading term is the one with the highest exponent. In this example, it's negative 4x to the fifth. My leading coefficient is negative 4, so this is a negative. And my exponent is 5, so this is a negative odd. So I just have to figure out where my negative and my odds intersect, which is this here, and that tells me the end behavior on my graph. It goes up on the left and down on the right, where again we don't really know what happens in between. So up on the left and down on the right is our official answer for our end behavior of this example. Let's do one more example of this one, and this one's a little bit more complicated because it's not an expanded polynomial form. It's in factored format. Now, factored format is going to be easier for other steps, but it makes it a little bit more work in this step, but not bad. All we have to do is figure out the leading term of the whole polynomial. Now, I can do that by multiplying out this whole polynomial, which is more complicated than what it sounds. It would have to be multiplied out like this. 1/4 x times 2x minus 3, 3 times 4 minus x twice. So if I wanted to multiply out that whole thing, it would take me a lot of work. I'd have to be doing a lot of FOILing and many other things involved. But since I only care about the leading term, all I really have to do is multiply the leading term of each piece. So here's a leading term, 1/4 x times 2x times 2x times 2x times negative x times negative x. And those are my leading terms of each piece. Now, if you didn't want to write it out expanded like this, that's fine. I'd still do the leading term of this up here. 1/4 x times 2x to the third times a negative x squared. And if I multiply all of those out, that will give me my leading term and hence my end behavior. So I have 1/4 x times 2x to the third times a negative x squared. 1/4 x, 2 cubed gives me 8 times x cubed, and a negative squared is a positive, and then I have an x squared. So overall, 8 divided by 4 gives me 2, and I have x times x cubed times x squared. I add my exponents, and that gives me x to the 6th power. So this tells me that my leading term is a positive even. And what do I know about evens is they end in the same direction, and positives means that they both end up. So my end behavior looks like this, which is up on the left and up on the right. So there is my end behavior of this example. I'm going to stop this video here, and in the next video, I'm going to be showing you some more steps of how to graph all types of polynomial functions.